Welcome! In this series of videos, we will look at software add-ons for both the PowerBasic console and Windows compilers. Today we will look again at SQL Tools, an add-on from Perfect Sync software, and running SQL Queries. Following on from the last video on SQL Tools, where we connected to a SQL Server database, we now want to build up a SQL query to run against that database. The SQL Tools library will be used to both connect and run the query, giving us back a record set of data comprising of one or more rows of data, which we can then use within our application. In this series of videos, we'll be covering topics which are common to both the PowerBasic Windows compiler and the PowerBasic console compiler. In order to do this, I've set up a small common library to allow us to display information on the screen from a program regardless of whether you're using the Windows or the console compiler. There are three basic functions in this common display library. There's prep output, log, and wait. At the end of our last video on SQL Tools, we had successfully connected to two separate databases at the same time. What we're going to do today is we're going to pull some information out of those databases. We're going to read data within a table. The database we'll be using is a SQL Server database, and we'll be using the SQL Tools Professional. If we have a look at our code, we've set the program up to look at two different databases, a food store database and a YouTube projects database. We're holding these in a global array, and we are preparing a connection string for each of the databases, connecting to the database and reporting the status that we have in fact successfully connected. Then connecting to the second database and doing exactly the same. Now we've prepared a generic user OpenDB function in our shared library, and this is calling the underlying SQL Tools functions to perform the operation of opening the database. Now, what we're going to do today is a piece of code in here, and this code is going to read data from a table. So we're going to create a function to perform this. Now we're going to pass a single parameter to this function, being our status variable. The function itself will return true if we have successfully read data from the database, and it will return false if it does not. If it returns false, we will display on the log what the status of the connection problem actually is. Let's create this new function. And there is our single parameter being passed to the function. In this case, it's a simple string. Should anything go wrong with running the query we're about to set up, this will have the status of the failure. So, since we're going to be running a piece of SQL, let's have a look at SQL Server itself and try our SQL out there first. This is our food store database, and these are the tables within that database. The SQL Server Management tool can quite easily generate the SQL for you by right-clicking on the object. And we want to select, in this case, the top 1,000 rows within that table. Now, in this case, there are only 4 rows of data within this table, and the SQL in the top window here is to select, in this case, the top 1,000 records. Now, as there are only 4 records, we can exclude this piece of SQL, and it is then listing each of the columns it wishes to select from that table. It then specifies the name of the database, the owner of the object, and the object you're actually querying, in this case a table. Now, as we know we'll be connecting directly to the food store database, there's no need for this part, but we can leave in the owner of the table which in this case is the database owner, and the table itself. If we just execute that query, we get this information back. It pulls back 4 records and 2 columns within each record, one being the index food type and the other being the food type. So if we copy this SQL and go back to our code, we'll create a local variable to hold our SQL string. And there is our line of SQL query language to run against the database. Now, how do we go about using SQL tools to achieve this? Well, we're going to be calling a number of functions within the SQL Tools library, and we need to test the output of each of these functions. So we'll create a local variable to hold that result. And the very first function we're going to be calling is the SQL statement function. And the SQL statement function takes a number of parameters. It takes the first parameter being the handle of the database. Now we know in this case it's the fooddb constant we set up earlier, which happens to equate to a 1. Its next parameter is the statement number. Now, as I said in the last video, there's a difference between the SQL Tools Standard and the SQL Tools Professional. And most of that is to do with the number of database connections you can have and the number of SQL statements you can set up concurrently. However, this is our first statement, so we'll mark it as statement number 1. The next parameter is what we're actually passing to SQL statement to tell it what we want to do. In this case, we want it to do this immediately. And the final parameter is our SQL string. Now, having got all that in place, this will effectively parse the syntax of the SQL statement we're giving it. So if this actually fails, it means that we've done something wrong in the SQL statement. SQL itself cannot understand what we're asking it to do. So because of that, we need to test the value of this result. We're quite simply using a test for the value success or success with info. If this parses OK, we'll get to this part in the code. If it does not parse, then we have an error in our SQL. And this could be because we made a spelling mistake or a syntax error in the SQL statement. So what we'll want to do here is immediately pick up, using the function we created in the last video, the status, which will contain the error that SQL is giving us back. And then having done that, we can then close off our SQL statement to free up the memory actually set up. And the close statement command again takes 2 parameters, one being the database handle and one being the statement handle, which will match up with what we used to open the statement in the first place. And if the SQL has actually failed, then we will return false and the value back to the calling routine of strStatus. Now, just to test that works, we know that this particular bit of SQL actually functions quite happily. So let's misspell something in it just to force an error to test our error handling. So let's try compiling that now, which compiles quite cleanly, and let's try running a program. There we are. It has opened the food store database successfully. It's telling us that the processing fails because there's an incorrect syntax near the keyword from. Now, admittedly, the error was actually here, but like all error messages, they can't always exactly specify where the problem is, but there is a syntax error. Now we know what the error actually is, so we can remove it quite happily. But it's always good to test your error handling early on in the stage to make sure that if an error does occur, you can pick it up. So, what do we do if the SQL does actually parse correctly? What's the next stage? Well, the next stage is a do loop. Because we don't know at this point how many records are going to come back from this database, we'll have to read the records one at a time. So we're going to use the SQL end of data function within the tools library. And again, we'll need to pass it two parameters to say which database and which statement this refers to. Within this loop, we're going to have to read each record that SQL is going to pass back to us. So we're going to have to call another function. And in here, we're going to use the SQL fetch result function. And again, we'll have to pass it the same two parameters. And another constant to say we're looking for the next row. At this point in time, we haven't read any rows, so this would give us the first row. And with all the other statements, we'll have to test to see did we manage to get a row or not. Now, if for some reason we didn't manage to get a row, we have to handle the error. So there are two possible errors here. First of all, the table might be entirely empty. There could be nothing in the table. Or something could have gone wrong with fetching the result. Perhaps the connection to the database has actually dropped. The first one to test for is the table empty? And we can use the SQL noData constant. And what we'll do in here is we will return the status of no data, and we will clear out any error messages there are. So, what if it's an actual error? In this case, we will record the fact that it's an error by returning our SQL errors and exiting our loop. So, what do we do if we're getting this far and we do have a record? How do we handle it? Well, first thing to do is let's clean out any statuses that are lying in the errors. And what we need to do is work out, we know we have a record back, but how many columns are in that record? Because we don't know what SQL we may be running, there could be one or many columns within the record. I think we'll create a local variable to store the number of columns. And as we're going to be cycling through these columns, we'll have a variable to hold the column number. So because we're reading many records back from the database, you only want to work out how many columns there are the first time. You don't have to work out every single record you pull back, which could be an overhead if you're pulling back hundreds of thousands of records. So we'll also put in another variable to work out how many records we've brought back. And we'll call this row count. Now initially, row count will be 0. And if row count is 0, we can pull back the number of columns. And there's another function we can use to do that, which is called SQL result column count. And again, we have to give it two parameters so that SQL Tools knows which database and which statement it's dealing with. And at this point, long columns would contain the number of columns within a record. Now, it'll also be useful is to actually pick up what the names of the columns are. Now we know from the SQL we looked at earlier below we're going to pick up two columns, and we know the ordinal position of those columns. If we look back at our SQL, the first column is going to be an index, which in this case is the number of the food type, and the second column is going to be a string, which is basically just a string of data, which is the food type itself. So we know, looking at our code here, that these two values are fairly well set. However, you will be making generic queries where the SQL, which will not necessarily be pre-known by this routine. So what we'll have is, I think we'll set up a couple more variables to keep track of two pieces of information, one for the headers and one for the data on the record. So SQL info will be our headers, and SQL value will be our data. So having prepared those variables, we'll now have to look at each column within the record we've been given back. So a simple for next loop should perform that function. Now we'll put another test in here to see if it's the first record we're reading, and if it's the first record, what we'll want to do is we'll want to pick up and populate the column headers. So we're going to be appending to the end of the SQL info variable, and we're going to use another function from inside the SQL Tools library called result column info string. And again, as with all the rest, the first two parameters refer to the database and the statement. The next parameter is the column we're actually referring to, which is our for next loop. And the final value we're after, we use a constant from the library for that one, called rescall label. And this will pull back the column name for that particular column from the record set. And since we're making this a pipe delimited list, which we can use later, we're tacking on a pipe to the end of it. Now that handles our column headers, the names of each of the columns. Now we have to pick up the value of the data within that column. And again, since we're pulling back many columns, we want basically a long string delimited by a pipe character. And to get the value of that actual column back, we're using another SQL function from the Tools library called result column string. And again, we'll be using the first two parameters being the database and statement name, and the final one being the column. And we'll tack a pipe character onto the end. Now I'm taking a fairly generic method of getting this information back from the database. At this point, we have no idea what type of column we're pulling back. So we're using a very generic function which basically converts whatever that is, be it a number, a string, or a date, into a standard string. And once it's in a string, we can append it to our string we're building up for the value, and we can pass this back to the routine that's calling this. And having built up all that information, what we'll want to do is a quick operation on the headers just to trim off any residual pipe characters, and we'll do the same for the value. Now, at this point, we have got our record back from the database. Now, just so we can see what's actually happening within a routine, I think we will push that information out to the log so we can see it. So we will test to see if we run the first row or not. And if we are in the first row, we will fire out to our log what the column headers actually are. And at this point, we can then do an increment on the row count to be ready to go on to read our next piece of information. And also what we'll want to do, since str value contains the data values for the record, we'll push that out to the log as well. So we're going to have at the beginning the column headers, and for each data record we'll have the word data followed by the delimited list of data within the record. Now let's just do a quick compile to make sure we haven't missed anything, which we have. We need the word until in there. And we need a then. Right, the program seems fairly happy. Before we run our program, let's have a quick look at the data again to see what we should see back from the system. We have two columns, IDX food types and food type, and we have the data for the first column and the data for the second column. So we go back to our code and run it now. There we have our log. The food store database has been opened successfully. Our column headers are the IDX food types and food type. And for the data, we have our two columns as expected, first column being a number and the second column being a string. Now we're getting a processing fails no data message at the end here. Let's just double check. We have not actually passed back a true. Which is what we're using to determine whether it's actually functional or not. So let's try that now. Much better. So we're getting headers and we're getting the data, and we're getting a message to say the processing has worked. Now, if we have a quick look back at our function, we're passing a status variable into the function so we can pass back the value if there's a failure. We have specified our SQL. We have used a SQL statement to parse our SQL to make sure that syntactically it's not going to have any problems. If, for example, you're trying to query a table that does not exist, then it would come back with a message. If your syntax is actually wrong, like you spelled something wrong or you've missed a comma, again, you'll get an error message. If the SQL statement function passes, then we start to read the data until the end of the data. We specify the database handle and the statement handle, and we're attempting to fetch a result, picking up the next row, checking if that's successful, pulling back the column count to see how many columns we're getting back. For each column, when it's the first row, we're pulling back the header information, in other words the name of each of the columns. Otherwise we're pulling back the data, and we're accumulating that data in a string variable. And by the time we get to the very end, we close down the statement. As you'll see, this has been a successful method for actually reading from the database, but it is quite wordy. There's a lot of code to type to run what is quite a simple piece of SQL. What we're going to do in the next video is we're going to create a generic function which you can call, regardless of the type of SQL you're trying to run, to pull back a data set, without having to type this for every single piece of SQL you wish to run. But that's it for today. I hope you've enjoyed the video. Thank you for watching.